So ladies and gentlemen, what we want to do, what they're asking us is to determine if these are equivalent ratios. And equivalent ratios are going to be very, very important. And I'll give you one example of an equivalent ratio that maybe you're probably familiar with. 1/2 and 2/4. Right? Would you say that those represent the same amount? If I said I had 1/2 of something or 2/4 of something, would you say that is an equal amount? Yes, these are equivalent. And the reason why they're equivalent is we can rewrite one. All we need to do is multiply this left equation by 2/2, and therefore now I have it as 2/4 and 2/4. You could also divide the left side by 2, and then you get it to 1/2, right? But that's how you're going to be able to show that equivalent ratios. If you can either multiply it by an equivalent fraction or divide it by an equivalent fraction, and you get the same ratio, then you have equivalent fractions. So what we need to do to determine if 7/6 and 52nd 48ths are equivalent is we need to see, all right, can we multiply this by an equivalent fraction or divide it by equivalent fractions where we will obtain the exact same value. So I like to usually do multiplying rather than division. And if I wanted to multiply, I can see that, well, to get to 7, is there a number I can multiply 7 by to get to 52? No. Is there a number I can multiply 6 by to get to 48? 6 times 8. Right? So if I have to multiply 6 times 8 on the denominator, but if I multiply 6 times 8 on the top, then what I'll have is 56 48ths and 52 48ths. And therefore you guys can see that these are not the exact same, right? You always have to multiply by that same number on top and bottom, but when I do that, I notice that these are not equivalent. So therefore these are not equivalent equations. Or I'm sorry, equivalent fractions or equivalent ratios. And that's all you guys gotta do is determine if you can see it multiplied.